This will be a quick tutorial on how to navigate around Vernier Graphical Analysis, specifically how to linearize a graph. But before we get into that, we'll be just going around some basics to start off. What we're going to do is we want to import our data. For the sake of this tutorial, I'll be using some of the data I've collected for my freefall lab experiment. The data was collected using the Tracker video analysis software. So you simply go and you copy paste your data into these columns that you see over here. So by doing so, you can see I now have my data, but we're encountering two main issues. Number one is that the graph is of really small scale, so it is not a good quality graph, and it is not big enough for us to really understand what's going on, even though we can technically see the motion of the object. And the second problem that we are facing right now is that, as you can probably tell, our axes have no title, so it's just X and Y. So to first fix this problem, it is very simple. You simply go and you double click on the column that you first want to change. In this case, I'll go with X. Double click once again, and you can see here, column definition, you can change your name. In our case, the X data and the X axis is going to be the time. So you enter time, short name is going to be T, and the units are going to be seconds. So you can see now it has updated here and here as well. And we can do the same accordingly for Y. So double click yet again, column definition, name is going to be height for our experiment. Then H, you can use Y as well, but I prefer H, and then M for meters. So now our axes have updated. We have yet another problem to face, which is the small scale graph. Now this again is very easy to tackle. You have to notice how the biggest value that your two variables take. So in the time, it is approximately 0.7, whilst in height, it is 2.4. And you can see that our axes have way bigger scale to support bigger values, of course. So we are going to kind of personalize this for our experiment. How we do this is we go on the axis we want to tackle first. I'm going to go with the y-axis first. I double click on the axis, go to graph options, axis options, and here, starting off with the y-axis, I'm going to choose auto scale, and this scales it automatically. I'm going to do this step by step so you can see. Now it is even clearer, the motion of the object, but we want to change the x-axis as well, so it is even better looking. So again, double click on the axis that you want to change. Here on the bottom corner, you can see x-axis. We're going to go ahead and you can either manually put this or do auto scale again. In this case, I prefer to manually do it, so you can have both ways to do it if you want. So in this case, you put auto scale larger and you leave the first to 0. And the right one is going to be your highest value. So in this case, since we have 0.7, I'm going to put 1. Click done, and now you can see we have a perfectly fine looking graph. Now, next thing you want to add is your error bars. Generally speaking, you can have either individualized error bars for each point of your graph, or you can have a common error bar for fixed error for every single point in your graph. For the sake of the tutorial to move forward, I'm going to do the second one, but I'm quickly going to show you how you can do the first one in case you might need it for future use. So the way you're going to do this is you're going to go ahead and you're going to click data, you're going to click new manual column, and you're going to enter the title. For my title, if it's for the height, for example, I'm going to put H error. Short name doesn't really matter. I'm just going to put the same, honestly. And then for the units, it's going to be in meters, of course. So now you see we have another column, and here you can enter your individualized error. So whether it be 3, 2, 4, 1, whatever. But in this case, we're just going to use one fixed error for the sake of this tutorial. Moving on, now the next thing we have to do is the actual error bar calculation. So you can click on any point, double click, and then you can go to options, and now here you have your points. Actually, I'm gonna put it to yellow just so you can see the difference. And then you're gonna check error bar calculations, and now you have to choose either from percent or fixed value. In my case, I calculated for my experiment. You come in and you substitute the value for your percent. Since my percentage was fixed, I keep fixed checked and I enter 0.001. And now you can see everything looks a bit weird. You're gonna be like, oh my god, how do I fix this? Well, double click again and change the color, as we said previously, to red. Now it looks perfectly fine. The main problem encountering here is the uncertainty is so slow that it is barely visible. So for the sake of this tutorial, again, we're going to use a bigger uncertainty. So this way, using 0.02, we have now error bars for every point. Keep in mind, this is the way that you add error bars. They're common for each point and are not individual. But now you have your graph. Alright Bobs, that's it for this one. This video is part of a small series I'll be doing of tutorials for the Vernier Graphical Analysis software. Next video will be on how to linearize different graphs. If you found this video helpful, please consider dropping a like and commenting, and consider subscribing for more techie bites like this one. See ya!